In this video, we're going to be looking at solving systems of linear equations graphically. And so when we're solving systems of equations graphically, three different things can happen. So the first thing that can happen is that, say we have two lines. We are graphing two lines, and those two lines intersect each other. So in this case, we have one unique solution. So we have line 1 and line 2. And in these cases, the slopes of line 1 is not equal to the slope of line 2. Okay, and so this would lead to the two lines crossing each other. And at that point of intersection would be our solution. Our solution would be that point of intersection. Where these two lines cross each other would be the solution. Now, the next thing that can happen is that these two lines are parallel to each other. And so when the two lines are parallel to each other, there's no solution in this scenario. But in this scenario, the slopes would be equal to each other. So the slope of line 1 would equal to the slope of line 2, but the y-intercepts will not be equal to each other. The y-intercepts will not be equal to each other. And in the third scenario is that these two lines, L1 and L2, are exactly the same. So they lie on top of each other. So if you graph them, the second graph will come in on top of the other one. So in this scenario, there's an infinite number of solutions. Infinite number of solutions. And in this scenario, the slope from the first line is equal to the slope of the second line, and their intercepts are also equal to each other. So we have equality across the way. So we have y equal to mx plus b, where m is the slope, and b is our y-intercept. So for all these equations, for infinite solutions, slopes are equal to each other. And the y-intercepts are also equal to each other. Okay, so let's look at our examples. So in our first example, we have 2x plus y equals 7 and x minus y equals to negative 4. And so let's graph this. So first let's solve for y. So we'll have y equal to minus 2x plus 7. So here the slope of the first line, m1, is equal to negative 2. And let's go ahead and graph that first line. So here, let's get some values for x. So when x is 0, y is 7. When x is 1, y is 5. When x is 2, y would be 3. So we have 1, 2, 3, 4, 5, 6, 7, and 1, 2. So we have 0, 0, 7, 1, 5, and 2, 3. So we have this line coming down here. So that's line 1. Maybe I should use a different color for okay, so let's try a different color. So let's see. So here, solving for y, I will have x minus y equal to minus 4. Moving the x over, I get minus y minus x minus 4. And so multiply the whole thing by -1. So we get y equal to x plus 4. So let's get some x value. So when x is 0, when x is 0, y would be 4. When x is 1, y would be 5. And when x is 2, y would be 6. So here we have 0, 4. We have 1, 5. So here's our point of intersection. And we have 2, 6. So we have our point of intersection, the point 1, 5. So our solution, this would be our solution here. And this is a unique solution. And now again, if we look at our slopes here, the slope for the second line is m2 is equal to 1. And the slope from our first line, m1, that's -2. So these slopes are not equal to each other, right? So we expect that unique solution. Okay, and we could also solve this graphically. Not graphically, but algebraically if we wish to. By just, you see here the two y values are opposite but equal in sign. So you just add down. So these will cancel out and you get 3x equal to 3. Divide both sides by 3. So x is equal to 1. Now that you have x equal to 1, you substitute it into one of those equations. Let's do it, say, into the first equation. So 2 times 1 plus y equals 7. So you have 2 plus y equals to 7. Subtract 2 from both sides, and we get y equal to 5, which matches our solution here. Okay, so you can do it both graphically and algebraically. You get the same answer. Okay, let's look at our next example. Okay, so in this example, we want to solve this graphically also. So let's solve for y. So we have 5y equal to minus 10x plus 20. Divide everything by 5. So we have y equal to minus 2x plus 4. And so let's solve this graphically. So solving graphically, so here, when x is 0, y is 4. When x is 1, y would be 2. When x is 2, y would be 0. So 0 is in the center, so 0, 4, 1, 2, and then 2, 0. So we have this line going this way. And then let's take our second equation, also solve for y again. So we get y equal to minus 2x, minus 2x minus 2, right? So x and y. So when x is 0, y is -2. When x is 1, that would be -4. When x is 2, y would be -6. So let's put in some values down below. -1, -2, -3, -4, -5, -6. So here, 0, -2, 1, -4, 2, -6. So here, all right, so we see that these lines are parallel, so no solution here. And again, if we're looking at this, we see the slope for the second line is -2. Slope for the first line is also -2. So both slopes are equal, but let's look at the y-intercept. So B2 is -2 here, but B1 is +4. So B1 is not equal to B2. So when the slopes are equal to each other, but the intercepts are not, then we have parallel lines and we have no solution. Now, what about if we did this algebraically? What would this look like algebraically? So we want the x's or y's to be the same amount but opposite in sign. So let's say if we multiply this one by -5, that whole equation, the whole second equation by -5, what would happen? So we get minus 10x minus 5y plus equal to plus 10. And so now when we put back the first equation, 10x plus 5y equal to 20. So now here, when everything cancels, you need to put a 0 to hold that position. So you get 0 equal to 30, which is a false statement. So whenever we get a false statement, we know the two lines are parallel and that there's no solution. So if you did this algebraically and you didn't do it graphically, and you got a false statement, you know that there's just no solution to the systems of equations. Okay, let's look at the next example. Okay, so in this example, they're saying they give you two equations here, and they say if there are infinitely many solutions and a and b are constants, what's the value of a? So here we see that we have infinitely many solutions. So we know that these two lines are lying on top of each other. Line 1 and line 2, they're the same exact line. So when they're the same exact line, that means that the slope of line 1 is equal to the slope of line 2 and the intercepts. B1 is equal to B2. So here, what I'm going to do, I'm just going to make them both the same size. So I'm just going to multiply this guy. I think if I multiply by, let's say, a -4, that should do it. That make them both the same size, right? So this become -20p plus 16q equal to minus 4a, and in this one, this is minus 20p plus, plus bq. So there's a q here, sorry. So there's bq equal to minus 9. So we have all the p's lined up, right? So this is what we expect to happen, right? The p's are the same size, right? So this means that because everything is equal here, that means that 16q is equal to bq, and minus 4a is equal to minus 9. Well, they only asked us to find a. So here, we just divide both sides by -4. So a is equal to 9/4. And here, if we wanted, we could see that, well, b is equal to 16. Okay, so that's a very quick way of doing it. A kind of longer way of doing this would be if I solve for q, take the first equation and solve for q, take the second equation and solve for q, and without showing the work, I'll show you that. So without showing the work, the first equation, we get q, solving for q, we get q is equal to 5 over 4p minus a over 4, and the second equation, we will get q, solving for q, q would equal to 20 p over b minus 9 over b. Okay, so this is a here. And then you just set these equal to each other. You just set, you can just set 20 over b equal to 5 over 4. And if you did this, you see that that would give you that b is equal to 16. And we know that minus a over 4, the intercepts now, minus a over 4 would equal to minus 9 over b. Well, we get b is equal to 16, so replace this with 16, and then we'll get, and then you give you a is equal to 9 over 4. So this way is a bit longer though. So if you wanted to do it like set them both up as y equal to mx plus b, this way at the bottom that I did down here, that's setting them both up like y equal to mx plus b, and then making that comparison. But the first way I showed you is much faster.